Hello and welcome to College Physics 1, Lecture 4, Units and Unit Conversions. As we have seen, in order to measure a quantity, we need to give it a numerical value. But a measurement is more than just a number. It requires a unit to be given. You can't just go to the deli, for example, and ask for 3/4 of cheese. It doesn't make a lot of sense. You need to use a unit. So in this case, maybe one of weight, such as pounds, so 3/4 pounds of cheese, in addition to just the number. In your daily life, you probably use the English system of units if you live in the United States, which is where my class is based. And so here we use things like inches, feet, and miles for distance. These units are well adapted for daily life, but they are rarely used in scientific work. Given that science is an international discipline, it is also important to have a system of units that is recognized around the world. And so, scientists tend to use a system of units called the International System of Units, which is commonly referred to as SI units. We often refer to these as metric units because the meter is the basic standard length used in this unit system. So, in Physics 1, the one that we're talking about, 3 SI quantities and units are used in our course. We use time, which is measured in the base unit of seconds, length, which is measured in meters, and mass, which in physics, the base unit is kilograms. In a chemistry course, you might see the base unit being just grams, but that's because of different scales. Now, for example, anything other than these three are combinations of them. So, for example, if we were to say, well, what about speed, right? Speed is meters per second or miles per hour. Well, speed, being meters per second, is just a combination of length and time, meters and seconds. So these are why we call these typically base units. These are the ones that all other measurements or units are based on. Now, of course, there are more units than just those of time, length, and mass. These are just the ones that we'll see in our class. So on the right, I threw in an image that shows some of the other SI units. So some others include the ampere, which is the base unit for electric current, the Kelvin, which is the base unit for thermodynamic temperature, the mole, which is a base quantity for the amount of substance. When you talk about moles, you'll usually see the number 6 times 10 to the 23, but we won't get into that. And we have the candela, which is the base unit for the intensity of light. So those are the 7 base units, but again, in our class, for our purposes, we mostly ever just use 3: time, length, and mass. So before we jump into things, let's ask ourselves, well, why do units matter? Right? Why does it really matter other than my deli example? Well, here's a very good example of why it matters. In 1999, the $125 million Mars Climate Orbiter burned up in the Martian atmosphere instead of entering a safe orbit from which it could be performing its observations. So, an engineer team provided critical data on the spacecraft performance, and they used English units. But the nav team assumed that this data was in metric units. As a consequence, the navigation team had sent the spacecraft flying too close to the planet and it burned up in the atmosphere. And it's crazy to think about. Looking a little bit deeper into this, the engineers specified that the amount of thrust required to steer the craft's trajectory in the units of British pounds, in other words, pounds of thrust. But the Jet Propulsion Laboratory assumed that the units were in newtons, another unit of force that we'll talk about soon. So the correction that they were trying to make accidentally applied almost 4.5 times larger thrust than it needed. And so it was basically just forced too hard into the atmosphere and it burned up. So of course, this is an extreme example. Hopefully, if any of us go into the sciences, we're not making $125 million mistakes because of something so silly. But it gives you a really big idea of how important units can be. So, let's first look at unit prefixes. So oftentimes units are related to their base units by powers of 10 using what we call prefixes. In other words, we might have meters, sure, but what if we have a ton of meters, a really big distance? Well, we can simplify that in scientific notation by using these prefixes. So these relate our smallest and biggest numbers to the base unit. For example, we use the prefix milli to represent 10 raised to the minus 3. In other words, 1 millimeter is 0.001 meters. Kilo is the prefix for 1,000, so 1 kilometer is 1,000 meters. Now note that quantities given with prefixed units like this are usually converted to their base units before you do any calculations. And you'll get used to this in my course. Before you do any mathematical calculations and problems that we work out, you need to convert to base units. In other words, if you're given something in kilometers, you have to put that first into meters and then solve. And once we start working on problems like that, you'll see why it is so important. So on the right-hand side, I included a table that shows all of the common prefixes that we might encounter. In physics, we might not see the most extreme, like tera or giga, or pico and femto. Just to give an example, a nanometer, for example, is 10 raised to the minus 9. Another random one, megameters, for example, is 10 to the 6 meters, which is a million. 10 to the 6 is 1 million, which I'm going to go on a tangent here for a second. The lottery Mega Millions, mega means million, so that roughly translates to million millions, which is pretty redundant if you ask me. But that's beside the point. So these are just common prefixes, so anytime if you hear me say kilometer, you should know it's 1,000 meters. If I say centimeter, you should know it's 1/100th of a meter. Micrometer, it's 10 to the minus 6, and so on. So just get used to these. You don't have to brute force memorize them right now, but just be aware that you will see a lot of these throughout the course as we go. So now, onto the first kind of mathematical situation we're going to find ourselves in, and that is unit conversions. So even after you sit through a course like this or multiple courses like this, most of us here in the United States still think in English units. The signs on the side of roads still measure speeds in miles per hour. We think about things in feet or yards if you think sports, such as football. But that's mostly a United States thing. It's loosely used occasionally in other countries, but pretty much the rest of the world uses SI units. And so, unfortunately, that means we have to convert between the two pretty commonly. And so the purpose of the rest of this lecture is to learn how to go about these unit conversions. To begin, we need to consider unit conversion factors. So one way of performing a unit conversion is to notice that, as an example, 1 mile is 1.609 kilometers. Okay, so that's just a relation. By definition, 1 mile is 1.609 kilometers. If you took the ratio of those two numbers with their units included, it's always equal to 1. Because these two things are identical, 1 mile is 1.609 kilometers. So if you divide one by the other, you're dividing it by itself just to give you 1. And it doesn't matter which order you do it. So anytime you take the ratio of two values and it equals 1, we call that a conversion factor. These are useful because if you multiply something by these conversion factors, these ratios that you see, you're just multiplying by 1. So you're not inherently changing the problem that you're working on because you're just multiplying by 1. I've included some common conversion factors in the table on the right-hand side here. There are many more than just these, but these are some of the ones you might encounter most frequently. So you can use this as a reference. Those of you in my course, some of these are given on a formula sheet for an exam, but you can also find these usually on the front cover or back cover of a textbook as well. So, we know we have these conversion factors, we know we need to convert between units, so how do we actually go about doing that? Well, here's the steps in a unit conversion process. This might be a lot to take in at first, but that's why on the next slide we will do several examples. So, First, start by writing down the quantity that you wish to convert. So, if it's some number, write that down with its units, and that's the first step. Basically just writing down your number. Next, you need to find the appropriate conversion factor, like we just talked about, to multiply by. In other words, if we want to go, say, from feet to meters, find the conversion between feet and meters and multiply by it. Next, you'll cancel out the original unit, and then calculate your answer, which should now, if you set everything up right, be in the right units. Once you've done everything, then the last step is just to kind of check that you have the proper number of sig figs. So a list of steps like this is often meaningless unless we actually apply it. So let's go ahead and do 3 examples of unit conversions. We'll start with some pretty simple ones, and then the last one will involve multiple steps. So here I say convert the following to units of seconds, kilometers, and meters per second respectively, meaning for number 1 we're going to convert to seconds, number 2 to kilometers, number 3 to meters per second. So let's begin with number 1. We start with a value of 3 minutes, and we are told to convert this to seconds. So you begin by writing your number. So it seems weird, but write it again. So we have 3 minutes. Okay, that's step 1. Start with the quantity you want to convert. Step 2, said to multiply by the appropriate conversion factor. So we're going to multiply this by some conversion factor. So what I'm doing is drawing the parentheses to get us ready for that. So we need to convert minutes to seconds. So we need to know what the conversion between a minute and a second is. This is one we should probably know already, just ourselves. There are 60 seconds in a minute. So we have to figure out, do we put the 60 seconds up top or the 60 seconds on the bottom? And so this is a very important point. Right now, minutes are on the top over here. So to get our minute units to cancel out, we need to have our minutes on the bottom in our conversion factor. So for every 1 minute, there are 60 seconds. So this is our conversion factor. Step 2, multiply by a conversion factor. There are 60 seconds for every 1 minute, and the minutes had to go on the bottom so that they cancel out with our original units. In other words, we have minutes divided by minutes now, which just leaves behind the units of seconds. So that was step 2. Step 3, I accidentally just did already. Step 3 was to cancel out the original units, so I just did that. We canceled out our minutes. So step 4 then simply says to calculate. We have 3 times 60 seconds, which is 180 seconds. And thus, we have our answer. Now we can check that this is in the proper number of significant figures. On the left-hand side, we started with 3 minutes, 3.0. Remember, any non-zero number is significant, so 3 is significant. And trailing zeros after a decimal place are significant. These are both significant, and so we have 2 sig figs, so our answer should also have 2, which it does here. 180 without a decimal place has 2 sig figs. So there's our solution. Okay. Number 2, convert 60 miles to kilometers. So again, you should start by writing your number, 60 miles, and we need to multiply by an appropriate conversion factor. So again, I'm going to set up my parentheses. You don't have to start by writing them out like this, but I like to do that. So we know, converting from miles to kilometers, we can look this up if we don't memorize it, but 1 mile is 1.609 kilometers. So we need to again figure out which side the miles goes on. Is it in the numerator up top or the denominator on bottom? We need our miles units to cancel out, so that means our miles have to be on the bottom again, like last time. So for every 1 mile, there is 1.609 kilometers, km. So that was step number 2, multiply by the appropriate conversion factor, going from miles to kilometers. Step 3, cancel out your original units. So here we have miles on top, miles on bottom, so the mile units will cancel out. That is step 3. Step 4, calculate your answer in the desired units. So we have 60.0 times 1.609 kilometers, which should give us, let's just say it gives us, if we plug this into our calculator, 96.54 kilometers. So let's say that's what our calculator told us. Last step is to check for sig figs. Well, we started with 60.0. These are trailing zeros with a decimal place. They are significant. So we started with 3 sig figs, so our answer should also have 3. Right now, what I wrote is what my calculator told me. That has 4 sig figs. So we need to fix that. It has to only be 3. And so that will leave us with 96.5 kilometers. We don't know for sure what the next decimal place is, so we don't want to give more information than we know. Okay. One more. This one will involve an additional step. We're now being told to take 65 miles per hour and convert that to meters per second. Okay, well, the first thing to note, I'm going to write this again. Step 1, start with your number. I purposely wrote this as mph because that's how we see it in the United States on, say, street signs. Miles per hour is the same as writing mi over h. Let's say hr, so miles per hour. So that's the same thing. I like to write it like this because it shows very clearly which one's in the numerator, which one's in the denominator. Just having mph can be a little confusing. So that was step 1. Start with the quantity you wish to convert. Step 2, multiply by an appropriate conversion factor. Now this is where it gets interesting because, again, I've said this I think twice now, it's going to involve an extra step here. Because we have to take our miles and convert it to meters, and we also have to take our hours and convert it to seconds. So we're actually going to have 2 unit conversions to do here. Let's just start with distance. So we're going to go from miles to meters. So in this case, let me see, meters per second. Okay. So in this case, let's say we have miles on top. So that means, again, we need miles on bottom. This time we're going to meters, not kilometers. So for every mile, there are 1,609 meters. So again, let's cancel out our original units of miles. There we go. That was step 3. But we do have an issue. If you look at this right now and we solved, we would get 65 times 1,609, but that leaves us with meters per hour. That's not what we're aiming for. We want meters per second. So we also have to convert our time. And so we need another conversion factor here. Notice that the hours are on the bottom, so we're going to need to have our hours up top this time so that they cancel out. In other words, we have hours over hours. Okay, in 1 hour, we know there are 60 minutes, and there's 60 seconds for every minute. So that gives us 3,600 seconds in every hour. So we cancel out our original unit of hours, and now look at what remains. We have meters and seconds. Indeed, that's what the problem asked for, meters per second. So now we can finally go to step 4, which is to calculate your answer. So here we're going to take 65 times 1,609 divided by 3,600. This, let's just say, comes straight out to being 29 meters per second. Your calculator might give you some decimal places, so just make sure you get the right sig figs, which is 2. And that's it. So there are situations where we'll have to do some conversions like this in the middle of bigger problems later on. So just be aware that these conversions are very important. Okay, I think that's a good point to stop. So this is basically all of our primer material. We've gone through our mathematics review, we've learned about scientific notation and sig figs, and now we've learned about our units and unit conversions. We have the foundation now to begin our real physics material. So in our next lecture, we're going to start talking about motion, position, and time, as well as speed and velocity. So with that, I wish you the best, take care, and I will see you in the next video. Have a great day.